Hello everyone, I am Soumyashree Senapati, Assistant Professor Vedang Institute of Technology. In this class, we will discuss about compound stress and strain. So, in our previous classes, we know what is stress and strain. Now, we will learn how compound stress and strain works. So, before going to compound stress and strain, we will learn complementary shear stress. So, how complementary shear stress produces? Like, now we will take this rectangle element and name it as ABCD. Okay. So now we will fix the end support of this rectangle. Okay. So here one shear force will act and we will name that as tau. So to know that if the rectangle is in equilibrium or not, so we will free the end support. After freeing the support, so what happened? Here also one shear force will produce. So now let's ignore this part. Okay, if it is in equilibrium condition or not. So if anyone says that yes, it is in equilibrium condition, but no, how, like the magnitude of the shear stress is same here and it follows the opposite direction. Also it says parallel to each other. Okay, we know that different shear forces are act parallel to the object. Okay, and also contact area between them is same. So what happened? Now they will form one couple here. Okay, to counteract this couple, now here will be one shear stress will be produced here. Okay, so as it produced here for this tau we have couple in clockwise direction, right? So for this tau dash we will name it as tau dash. For this tau dash another couple that will form and it will be in anti-clockwise direction. Okay, so now we will calculate this couple. Okay, so here with this diagram we will calculate the couple and check either they are in equilibrium condition or not. Right. So here what happens? In this direction tau will form and also here tau dash and tau dash. As you can see here, you can see tau and this tau dash are in same direction. If they come across, they will be in same direction. And here what happens? They are distracted from each other, right? Also here you can see they are coming towards each other and here in this diagonal you can see they are distracted from each other. Okay, so you can see that shear forces are in one diagonal, like this direction they are coming towards each other. Okay, so to check equilibrium, we will take couple C clockwise direction. To calculate this, what we will take? For clockwise will be clockwise couple occurs due to this shear force. Okay, so this shear stress. So what happened? We will take tau. Tau is acting here in this plane, right? So we can take T as the thickness of this rectangle, right? Thickness of rectangle ABCD. We can take it as the T as thickness of rectangle ABCD. So we are calculating couple for ABCD plane. We have already taken tau as our shear stress. Now we will take this AB plane, this AB as this to this length to as what? This is our shear stress and this is our perpendicular what? Perpendicular to the AB plane. So we will have force here. Okay, we will have the force here. So shear force into perpendicular distance. To AB plane, we will have AC as perpendicular to AB. Now, here. Now we have clockwise couple for tau. Likewise, we will calculate couple C dash for anticlockwise, that is tau dash. Okay. So, same wise C dash will be tau dash, tau dash will act here in this plane. So, we will take AC for the shear force. Okay. And perpendicular distance, for AC, we can take the perpendicular distance as AB or else CD. But we know in case of rectangle, AB equals to CD, so we can take anything like AB or CD. Okay. Now we have C and C dash, right? To check either they are in either they follows equilibrium condition or not. Okay, we can just write these two things and erase another parts. Right. So we have C as tau into AB into AC. AB into thickness as we are taking the area. As we are taking the area of this, so we are taking AC and we have taken here the T as thickness, right? C dash as tau into AC into T into AB. To check the equilibrium condition, we can write AC equals to tau dash into AC into AB into thickness. Here is the equation we have. Okay, so we can cancel this T with this T, AC with AC, AB with AB. Now we have tau as tau dash. Okay, so we can say here shear stress is equals to complementary shear stress. Complementary shear stress is what? Here we have the tau dash for the equilibrium of this couple. Okay. So we can write it here as shear stress equals to complementary shear stress. Okay. So that is every shear stress is accompanied by what? Equal complementary shear stress on a plane at right angle. That does mean if in case of rectangle we have the shear stress here, so we will have the complementary shear stress as as right angle to each other. Okay, if this is your tau dash, this will be your tau, and if this will be your tau dash, this will be your tau, that act right angle to each other. For note, we have existence of complementary shear stress may be important factor during failure of an isotropic material. Okay, such that timber which is weak in shear that along the grain. Okay, in case of failure of isotropic material, we will need complementary shear stress. Okay, in this class we have learned complementary shear stress. In our next class we will learn principal stress and strain, and lots of we will solve a lots of numerical regarding that. Thank you so much.